Hi everyone, thanks for watching this Connect with Remedy webinar. My name is Doug Reif and today's topic will be the new Remedy 9 AR Log Analyzer. Today I'll show you a quick overview of the Log Analyzer. We'll talk about when to use it, what the components are, how to use it. I'll show you some scenarios and examples of using it, and then we'll talk about some possible outcomes and what you can do with what you find in the Log Analyzer results. Then I'll show you some references. First, let's start off with a quick demo. I'll locate some logs, we'll run the utility and I'll show you the results. Then we'll walk through several of the screens so you can see what it looks like. Here's a folder with some log files that I pulled from my system. Generally, I want to look for the API, SQL, and filter logs. In this case, I grabbed just a bunch of logs from the DB directory and I just dropped them all here. The log analyzer is smart enough to only look at the logs that are relevant. So once I've run this through the log analyzer, I'll show you the output that I get. The log analyzer creates two outputs. First, it creates the final.log, which is a cleaned up and parsed file that includes all of the input files. So all the API, SQL, and filter logs are pulled together and lined up by time and cleaned up and put into the final.log. And finally, the max folder will contain the actual results. So I'll open it and I'll just open up index.html file. The main page of the log analyzer first shows some general statistics such as the start time, the end time, the elapsed time, total number of APIs and escalations, etc. And you also get an idea of how many threads were in use during these logs. The first place to look is the top end API aggregates. This, in my case, shows the 200 longest running API calls. So you can see here that I had an API call that took over 21 minutes. You can also drill down into the exact API call to see what took all the amount of time. So I get two options here. I get the beginning and ending line numbers for that API call. If I click on the first number, I'll get taken directly to the beginning of the create entry API call in this case. And I can see all the different filters and SQLs that made up this API call. This particular API call probably took multiple pages, so from the top I can click a page and advance and move forward through the logging. And one thing you can see is that there was a lot of different filters and a lot of different SQLs that took the total amount of time. But this makes it a lot easier to troubleshoot performance issues. Next, I can look at the top queued in, and this tells me if there's any API calls that had to wait for an available thread. And you can see here I had to wait over 11 minutes for a thread to become available. Next place to look is the SQL. So this shows the top 200 longest running SQL statements, and here I have a SQL statement that took over 17 minutes to run. Again, for troubleshooting a performance issue, this is a great place to look. That was a quick overview of what the log analyzer looks like. Now let's talk about when to use the log analyzer. You can use it to troubleshoot performance issues. When you have users that are reporting a problem, maybe one or more or a group of users, you can use the log analyzer to take the logs that you've gathered and to try to identify exactly what is causing that performance issue. If you have slow integrations, again, you can use this tool to identify what the cause was. Even if you have a general performance issue where you just have what feels like sluggish performance or many users performing many different activities seem to be sluggish, it's a good time to use this tool to try to see if you can find a root cause for that. Another great use of this tool is to proactively monitor performance. So even if users aren't reporting a problem or you're not seeing sluggishness overall, you can still use it to proactively make sure there's not something going on that maybe just hasn't been detected yet. So if you just gather a set of logs for, let's say, a couple hours during the day, you can just go and look and see if there's any slow APIs that perhaps need to be tuned. You just haven't been aware of them yet. And you can focus on the APIs and SQL statements. You can also check to see if you have the right number of configured threads. You can see if you have users waiting on threads, and if you do, you may want to add some threads. So this is a great tool to proactively look at your settings and make sure that you're at peak performance. Now let's look at the components. What all do you need to analyze a set of logs? Well, first you need to download the log analyzer from the EPD site, and you just simply unzip the log analyzer package. There is no installer for this. You just unzip it into the directory that you want to use. Second, you're going to need some logs. Usually we recommend getting a set of SQL, API, and filter logs, but it kind of depends on what you're troubleshooting. And last, you need a use case. Now, some use cases will just be simply, I have a general performance issue, but quite often there'll be a very specific case, like a particular user experienced a particular type of slowness, like it was maybe taking 10 seconds longer than they expected, performing a particular action. So in most cases, it's really helpful to have a specified use case. Now the first thing you'll do after you unzip the log zipper is run the AR prepare logs utility. This is a utility that merges all your log files by timestamp. It unwraps each log file, so if you had a log that was a wraparound log where the beginning of the log wasn't actually at the beginning of the file, AR prepare logs will unwrap it so that the actual beginning of the log is at the top of the file. It can also reassemble individual lines that were broken by carriage returns. So for example, you might have had a SQL statement that included a carriage return in it, and that would have spanned multiple lines, but only the first line would have had the header information. AR prepare logs will put all that information onto a single line so that it has the header information that it needs to be able to parse it. It can also crop files by timestamp, and it can filter by client RPC number, RPC program number, or a queue. So you can, if you have a large file, you can choose to have AR prepare logs strip it down and only look at particular sections of the log that are pertinent to what you're trying to troubleshoot. There are several command line options when running AR prepare logs. The one that we're really concerned about is the -o parameter. So typically we're just going to run AR prepare logs with -o in some file name. By default we'll call it final.log. And then we'll provide the log file name or a mask like star.star or star.log. After you've run AR prepare logs, it's time to run the actual log analyzer, which is ARWKLGA. So this utility is used to calculate durations based on thread ID or queue. It will also sort and group the output based on some command line options that you provide. It can be used to create either text or HTML output, although we're going to focus on the HTML output today. Now here's a list of the options that you have when you run Log Analyzer, and we're not going to go through each one of them again, but we are going to focus on a couple of them. First, we'll look at the -s parameter. The -s, we're going to provide a value of max, so it will sort the output descending by the maximum execution time. We're also going to use the -w parameter, which will create the web format or HTML output. So let's look at how to use it. So it's pretty simple to use the utilities. They're command line utilities again. First you run AR prepare logs, and the common syntax is AR prepare logs with the -o and final.log as the output, and star.log or star.star depending on the file names that you have. This will combine all the star.log files in the current directory. It'll clean the logs with no filtering options, and it will put the output into a file called final.log. Next we'll run ARWKLGA, and we'll pass the -s parameter with the max option and the -w parameter with the max option, which specifies the name of the directory to put the HTML output. We'll also provide the -n parameter of 50, which says to log the top 50 longest executing items. And it will use final.log as input. Let me show you how I use AR Log Analyzer. I first unzipped the entire Log Analyzer zip into a folder called c:\login. I then created a couple of batch files that you might do as well. The first one was just called login.bat, and it simply had two commands, which were AR prepare logs -o final.log star.log. And then it ran ARWKLGA with the -s max and -w max, and used n of a value of 100. Now this time I wanted to record the top 100, and then in general that's what I do. I also created a batch file called logan_all. The difference is that the input parameters to AR prepare logs uses star.star. So often you'll find that your logs have a .1 or a .2 or some other extension on it, and you'll need something other than star.log. So in those cases I use the logan_all.bat file. Then from a command prompt, I change directories to where the logs are located, and from within that directory, I simply run c:\login, and then either logan.bat or loginall.bat. In either case, it will run the error prepare logs and the log analyzer, and it'll complete on its own. And once it's done, I can view the output. So this is what the output looks like. It creates a directory called max, and inside the max directory, I'll see all these files. The main one that I want to begin with is index.html. If I open that, that will provide the results. And this is what I showed earlier. This is what the results look like. It gives the general statistics screen to start with. So now I want to actually show you a real life scenario of using this and trying to identify problems and making use of the output. I've just opened the log analysis for some logs I was working with. If I go to the top N API aggregates, I see a few GLEWFs, which are queries, and I can see some of these taking a very long time. 4 minutes and 37 seconds is one of them. If I simply click on the first line number, it takes me right to the API call. And a GLEWF is primarily a query. And in this case, what I'm troubleshooting is a long query. A particular user performed a query that took longer than expected, in this case quite a bit longer. And so simply by clicking on that link, I can see right here exactly what happened. Here's the beginning of the GLEWF, all the way down to the end of it. And the only thing that really happened in here is you see this little piece where there was a select from the user cache table, and that's for the authentication. That was very fast. But the bulk of the time, from 4:56:11 to 5 o'clock and 48 seconds, all that time was taken up by this select statement. You can usually tell that between the select and the OK is while we were waiting for the database to return a response. And typically this means that it was a query that either didn't have proper indexes or simply couldn't use an index. To troubleshoot this further, we'd probably look at the where clause of this and see if there's something we can do, maybe to add an index, or perhaps this was just a bad query and we might need to instruct the user how to make it more efficient. We can take a look at some other examples here as well. There's a query here on AST base element. Again, we see the beginning of the API call. Here we see the select statement, and we see again that the major amount of time was just for the select statement up to the OK. In this case, there was a second select statement to do a count. And again, this took a bit of time. Both of these, this is the same where clause. So in this case, we're doing a query and then we're finding out how many records were returned. Both of them have the same where clause. So if we can make that query more efficient, we'd save a lot of time on this particular API call. So that's how you use this tool when you're looking for long-running queries. Now here's an interesting issue from a different set of logs. You can see the run times. I have a lot of API calls that are taking over 5 minutes. But for me, in particular interest is this API call on the problem form. If I click on the line number, we'll open it up and you'll see here's the beginning of a query, the GLEWF on the problem form, and you'll see the end of it down here. Now, as I mentioned earlier, the primary work done in a GLEWF is the select statement. Well, here you have the select statement, and you have an OK that's almost immediate. So where is all the time taken? Well, actually, the time taken in this API call is after that OK statement. It's here in this select statement from the user cache table, an update on user cache, and then OK, and you'll see at 12:14:43, which is roughly 5 minutes after the initial select statement, the API call ends. So what is all this time taken up? Well, one clue you have is the user_cache. User_cache is used just for authentication. And so what's happening in here is something to do with authentication. You can read between the lines here and understand that this particular environment is using external authentication. In fact, it's using area LDAP to authenticate. Well, the area LDAP authentication is not logged in the SQL API or filter logs, so you have no insight into that. You just have the gap in time. But based on the fact that this customer knows what they're using for authentication and these clues here that have to do with the user cache table, you can understand that this big 5-minute gap was a problem with authentication. Maybe you can troubleshoot that rather than troubleshooting a query. Now I'm looking at another set of logs so I can show you how you can troubleshoot performance issues with escalations. If I click on the top end for escalations, you'll see I get some great information about the escalations that we're running. In this case, I see the longest running escalation only took 2 minutes and 18 seconds, but I get a lot of information such as the pool that it ran on, the name of the escalation, and which form it ran on. So this is a great tool for trying to identify if you have escalations that are taking too long and perhaps need to be put off onto their own pool. Again, if I click on the line number, I get detailed information about exactly what happened, including the filter and SQL logging. Now that we've looked at the tool itself, let's look at what some of the possible outcomes might be. One of the outcomes is that you determine based on the log analyzer results that your server is working fine. If you have end users that are still experiencing performance issues, you might end up having a problem at the mid-tier or at the client side. You might determine based on the logs that your SQL needs to be tuned. So you might find that there's a SQL that takes particularly long amount of time to run, and the answer to it is to create indexes. Another possible outcome is that clients need to be configured properly. This might mean that the application preferences need to be set correctly for the overview console, or they may need to change the refresh rate. Sometimes the problem has to do with server limits and timeouts. For example, you might have found that you had a very long API call made to a plugin server, and eventually it timed out. Well, by reducing the server plugin default timeout, you can reduce the total amount of time that the API spent waiting for that. You can also change your page and chunking sizes for various components. You might find that the SQL needs to be tuned at the workflow or component level. For example, you might have workflow that's performing a particular SQL statement that's just inefficient. So the answer there might mean to redo the workflow so that it performs a more efficient query. Another possible outcome is that end users simply need to perform better queries. Oftentimes, users are allowed to perform queries that are inefficient. So simple user training might end up helping here. And lastly, one thing that might help is cleaning up some of your old data. So archiving and cleaning up old data is one way to improve performance in your system. So some of the activities that you might have to perform require the help of a DBA. And some other times it might require a support ticket to be created. For example, if you do find out that you have workflow that's performing inefficient queries, the solution might be to create a support ticket and have support try to determine the best way to make that query more efficient. So today we looked at how to run Log Analyzer, and I showed you some examples. We looked at the Log Analyzer itself, and I showed you how to identify some long-running operations. You can look at long-running APIs, long-running SQLs, and long-running escalations. We also looked at some possible outcomes and what the solutions to what you find might be. So thank you very much for attending this webinar. I left you some references here so you can look for the documentation and the download link from the EPD site. Thanks again for attending the webinar.